In this video, we're going to talk about rational exponents. But first, we're going to talk about the 5 exponent laws. Now remember, for the first 3 laws, the bases must be the same for each of the powers. And when I say the word exponent, like for instance, if you see a to the m, the exponent is m, the base is a. The power is a to the exponent m. So in this case, we have a to the exponent m times a to the exponent n. So two powers with like bases that we're multiplying. What we get there is a to the exponent m plus n. So for example, 2 to the exponent 3 times 2 to the exponent 4 would equal 2 to the exponent 7. Now, if we had a to the m divided by a to the n, in other words, two powers with like bases, then what we'll do is subtract the exponents. We had a to the m minus n. So for example, 2 to the 7 divided by 2 to the 4 will be 2 to the 3. And finally, if we take a power and raise it to a new exponent, then what we can do is multiply those exponents. So a to the m, the entire power raised to the exponent n, would equal a to the exponent mn. So for example, the power 2 to the 3 raised to the exponent 5 would ultimately equal 2 to the exponent 15. Now, another one is that a to the exponent 0 will always equal 1, no matter what a equals, unless a equals 0. Actually, the power 0 to the exponent 0 is undefined. But as long as a doesn't equal 0, then a to the 0 equals 1. So for example, 5 to the exponent 0 equals 1, and negative 6 quantity to the exponent 0 equals 1, and 3/4 to the exponent 0 equals 1. And finally, if we have a to the exponent negative n, what we can do is determine the reciprocal of a, which would be 1 over a, and raise it to the exponent n, or we could say it's 1 over a to the exponent n. So for example, 3 to the exponent negative 4 would be 1 over 3 quantity to the exponent 4, which is 1 over 3 to the 4. And 2 over 5 raised to the exponent negative 4 would equal 5 over 2 raised to the exponent positive 4, or 5 to the 4 over 2 to the 4. Now, a rational exponent is an exponent like 1 over n, or m over n, a fraction. And when we have a numerator of 1, then the rational exponent 1 over n represents the nth root of the base. So for example, 125 to the exponent 1/3 represents the third root of 125. Okay, so 125 to the exponent 1/3 represents the third root of 125. The third root of 125 is 5. And now, why is the third root of 125 5? Because 5 times 5 times 5, 3 of them, is 125. Okay? Another way of looking at this is as follows. Sometimes people, they want to find out what is 125 to the exponent 1/3. So they let that expression equal x. Now, what they can then do is raise the left-hand side and the right-hand side to the exponent 3. And so what they get is x to the 3 equaling 125 to the 1/3 to the exponent 3. Now, one of the rules that we just saw a while ago is that what we do in this case is multiply these exponents. Well, 1/3 times 3 is equal to 1. So we'd get 125 to the exponent 1, which is the same as 125. So ultimately, we'd be able to say x cubed equals 125, meaning x is 5. And since x is what we let equal 125 to the 1/3, and x is 5, we can say 125 to the 1/3 is 5. Okay? Now, I think once you get the hang of it, generally speaking, most people, if they're shown something like 125 to the 1/3, they intuitively realize, okay, I'm looking for a number that multiplies itself 3 times to give me 125. The answer is 5. Okay? So if we wanted to find out what is 32 to the exponent 1 over 5, the answer would be 2, because 5 2's multiplied will give you 32. Now, if we wanted to know the fifth root of 32 written this way, then we would also say that the answer is 2. The fifth root of 32 or 32 to the exponent 1/5 mean the same thing. And the fifth root of 32 written this way, again, is still 2 because 5 2's multiplied will give you a 32. Now, negative 32 raised to the exponent 1/5 will be negative 2 because you can take 5 negative 2's, multiply them by each other, and get negative 32. But negative 16 quantity to the 1/4 won't exist because you might be tempted to say, well, why isn't it negative 2? Because if you take negative 2 and multiply it 4 times by itself, you'll get positive 16. So what you know is you can't have, if you have a negative base and you're finding a root, it can't be an eventh root. It can't be, the root that you're finding can't be an even number. So right here we have 1/4. 4 is an even number, so we can't take the fourth root of a negative. But over here we had the root was 1/5. So the fifth root, 5 is an odd number. We can take the fifth root of a negative value because the base here was negative. Now, another one we have is negative 16 to the 1/4. There's a big difference between negative 16 to the 1/4, where the negative 16 is in brackets, or negative 16 to the 1/4, where the negative 16 is not in brackets. When the negative 16 is not in brackets, the base of the exponent is just the 16. So 16 to the 1/4 certainly equals 2. So we're able to say, since 16 to the 1/4 equals 2, therefore negative 16 to the 1/4, not seeing any brackets, I instinctively put them around the 16, not negative 16. Well, that would be negative 2. Okay? So to try to say it clearly one more time, if you have no brackets like that, then the brackets are going around the 16, not the negative 16. 16 to the 1/4 certainly exists. It's 2. So negative quantity 16 to the 1/4 is negative 2. Now, what happens if you get a fractional exponent, but the numerator of the fractional exponent isn't 1? Well, the real simple rule is make it 1. Okay, sounds like cheating, but you'll see what I mean. If I'm given 32 to the exponent 3/5, I say to myself, well, if it was 32 to the 1/5, I might be able to tell you what it is. It's the fifth root of 32. So what you do is make it 32 to the 1/5, and then put that 3 on the outside, because we know the laws of exponents tell us we're going to multiply the 1/5 and the 3 to give us 3/5. So we'll focus on the 1/5 first. 32 to the 1/5 is 2, but we put that 3 on the outside, so now it's 2 to the exponent 3, which is 8. If we have 4 to the exponent 5/2, that's like saying 4 to the exponent 1/2 to the exponent 5. Well, 4 to the exponent 1/2 is 2, so it's really 2 to the 5, which is 32. And finally, if we're given 100 to the exponent negative 3/2, what we can do is make it 100 to the 1/2, and then throw that negative 3 out, because we're not doing anything wrong mathematically. 100 to the exponent 1/2 is 10, but we still have that negative 3 that was originally in the numerator. Well, 10 to the exponent negative 3 is the same as 1/10 to the exponent positive 3. Well, 1/10 to the exponent positive 3 is 1/10 times 1/10 times 1/10. 1 times 1 times 1 is 1. 10 times 10 times 10 is 1,000. Now, what if we had 125/127 quantity to the 2/3? Well, this would be the same as 125/27 quantity to the 1/3 and then squared. Notice how we took that 2/3 and made it a 1/3 and then a squared. Well, 125/27 to the exponent 1/3 is the same as 125 to the 1/3 over 27 to the 1/3. Now, 125 to the 1/3 is equal to 5, because 5 times 5 times 5 equals 125. Okay? And 27 to the 1/3 is equal to 3, because 3 times 3 times 3 is equal to 27. So we can take this 125 to the 1/3, call it 5, and take this 27 to the 1/3 and call it 3. Now we've got 5 over 3 raised to the exponent 2. Well, 5 over 3 raised to the exponent 2 is like saying 5 over 3 times 5 over 3. Or in other words, 5 squared over 3 squared, which is what's shown here. 5 squared is the same as 25. 3 squared is the same as 9. So ultimately our answer is 25 over 9. Now, what if we have decimal exponents? Well, what we do is simply convert them to fractions in lowest terms and evaluate the way we already know how to do. So if we were given the expression 16 to the exponent 1.75, we could see multiplying 1.75 times 100 definitely gives us 175. And multiplying 1 by 100 definitely gives us 100. So we could change 1.75 over 1 to 175 over 100. Now, remember it says here, convert them to fractions in lowest terms. Well, 175 over 100 is not in lowest terms. We make it 7 over 4. So what we have is 16 to the exponent 7 over 4. We're going to make that 16 to the 1 over 4 and then kick the 7 out to the outside the way we've done here. Well, 16 to the 1 over 4 is 2 because 2 times 2 times 2 times 2 is 16, meaning the fourth root of 16 is 2. So we have 2 raised to the exponent 7, which is equal to 128. Now, what if we have this long expression here? Okay, we just figure, well, 4 to the 3 halves, that's the same as 4 to the 1 half, quantity cubed. Now, negative 1.5 is the same as negative 15 over 10, which is the same as negative 3 over 2, so we show that here. The third root of 27, quantity to the negative 2, is the same as 3 to the exponent negative 2. Okay, now 4 to the 1 half, quantity to the 3, is the same as 2 to the 3. If we have 16 raised to the exponent negative 3 over 2, that's like 16 to the 1 over 2, and then that quantity raised to the exponent negative 3. Well, we'll deal with these two first. 2 to the 3 is 8, and 16 to the 1 over 2 is 4, so we've got 4 to the exponent negative 3. And then this 3 to the exponent negative 2 is the same as 1 over 3 to the exponent 2, which is the same as 1 over 3 times 1 over 3, which ultimately equals 1 over 9. So we have this expression now, 8 minus 4 to the exponent negative 3 plus 1 over 9. Now, 1 over 4 to the exponent negative 3 is the same as 1 over 4 to the exponent positive 3. Well, that's the same as 1 over 4 times 1 over 4 times 1 over 4, which ultimately is equal to 1 over 64. So this 8 becomes 8 over 1, and we've got minus 1 over 64, and we've got plus 1 over 9. We need to get a common denominator of 1, 64, and 9, and the answer is 576. 8 over 1 is the same as 4,608 over 576. 1 over 64 is the same as 9 over 576, and 1 over 9 is the same as 64 over 576. So we end up with 4,608 minus 9 plus 64, quantity over 5,576, which is 4,663 over 576.